Hi students, let's look at this question here, which is on functions taken from the year 2021 of the A-level paper 2 question 3. So the function h is defined on all real value of x, hx, and gx is defined by all real value of x except for 0.2. Okay, so find gh2. I think the first part should be quite fast. What we need is just ghx as such. Then g is given by h. Will be this function here, right? So I'm gonna put that in. Maybe I just put 2. So meaning h2 means that I put 2 into the function of h. There will be half 2 squared plus 3 will be g5, right? G5 is actually just 5, 5. So this will be 5 plus 1, 5, 5 minus 1. So you can in calculator, this will be 1/4. Okay, that's it. I think the first part is pretty okay. Then we look at part 2. Part 2 is finding gx is 1.4. I think this is not an issue as well. So gx equals to 1.4 will mean that this is x plus 1 over 5x minus 1 is equals to 1.4. Then what we need to do is just solve this linear equation here. Shouldn't be an issue. Okay, expand 7x minus 1.4 x plus 1. So this is 2.4 6x. So x is given by 2/5. Okay, I think the first part should be quite okay. So let's look at the second part B. Okay, part B, the function f is defined by this rational function here where x is not equals to k. Okay, give an expression of k and explain why this value of x has to be excluded from the domain of f. Okay, so basically, you know that you cannot divide by 0, right? So f is undefined when 2x plus b equals to 0. So you know that this would let you know that x is equals to minus b over 2. Hence, k is equals to minus b over 2. Okay, so that's it. You just say that it is undefined at this is actually a vertical asymptote. Okay, so you just let this be it. So k is equals to minus b over 2. Great. So let's look at part 2. Let's try to understand what's going on here. So given a function f is such that fx is equals to f inverse x for all value of x in the domain of f. Okay, what does this mean? Okay, actually we just try to understand. Basically, this always holds true for all x. So all the entire domain, it will always hold true. So how does it look like? So I think we need to understand the question first. Firstly, let's say this is y equals fx. This is actually a rational function. We know that. So what happens is if I want to draw an inverse graph of this, the inverse graph of fx, this is fx, right? You know that it will be a reflection about this green line here, which is y equals x. Okay, so this is y equals x. Okay, let me just bring it up. Y equals x. Now for the inverse graph, just take note, the basically inverse graph just means that y becomes x, x becomes y. So when you draw the inverse graph, you'll be a reflection of this about the green line y equals x. So as I vary this, okay, you realize that when I reflect the blue color around about the green line, I'll get the purple line, right? So this is how it looks like. No matter where I go, it will be reflected. So if I reflect about the green line, it looks like that. Okay. Now, what is the next thing here is that just understand what when we say that fx equals to f inverse x, it just means that what we want to achieve is that both of these graphs superimpose. So there will be a sweet spot here where the green line and the purple line will superimpose. So this is it. Okay, so we need to work on to getting this value here, right? So how do we do that? I think the first thing is we just find the inverse function first. So let y equals to x plus a over 2x plus b. Then I'm going to make x a subject. So y 2x plus b is x plus a. 2yx plus by equals to x plus a. This will be x 2y minus 1, a minus by, x equals to 2y minus 1, a plus by. a minus b y over 2y minus 1. Okay, so this case here, what I get is f inverse, the inverse function will just be a minus bx 2x minus 1. Okay, so that's the inverse function. Now, what we need to do now is basically just equate them, because you need to equate them. Now, this is a rational function, okay? Rational function. This will equals to x plus a over, so this is your f inverse x, which we found. This is 2x plus a over 2x plus b. So you can see that by comparison, right? We know that b will be -1, because if b is -1, the coefficient of the coefficient of x for the numerator will be 1 on this side here, and the constant for the denominator will also be +1. So we know that b is equals to -1. Okay, that's that. So essentially, what we can do is, understanding that a fx f inverse x will just be equals to x plus a over 2x minus 1. So we need to work out the value of a. Now take note, for f inverse to exist, okay, this function here, for this to exist, right, the function of f has to be a 1, 1 function. So rational function by default would just be a 1, 1 function, okay? But there is a value here which will render it to be a horizontal line. So let me show you. This guy here, if I were to just move it, okay, here, this sweet spot here, as it transforms, yeah, there you go. The horizontal line here, this is not a 1, 1 function, okay? Basically, what happens here is when there's a value of a here, which will cancel it and make it equals to half, y equals to half. Basically, you can see this as, I would suggest what we need is, we do not want to cancel this out. So just take note that this, if I were to make this 2, okay, so this would just be, I factorize the 2 half out. This would be 2x plus 2a equals to 2x minus 1. Okay, so I factorize the half out so that I get a 2x here. I think this is easier to see. Okay, so what you want is that for f inverse to exist, okay, f has to be 1, 1. You do not want, if you do not want these two to equal to each other, because once these two equals to each other, it becomes a horizontal line, which this is not what you want, right? So in other words, what you want to achieve is actually 2x plus 2a cannot be equals to 2x minus 1. Okay, because it will, this will render, when these two are equal, this will render, you do not want fx to be half. So if these two cancel out, it will be half. Understand? So that's the idea there. So a cannot be equals to minus half. Okay, that's that. So this is a graph here. You have to, they will overlap each other when b is -1, as you can see here. But when it's equals to minus half here, it will just be not a 1, 1 function for the fx. Okay, so that's the idea there. So there you go. Okay, that's it. A not equals to minus half, a real value. That's the idea there. Okay, let's look at part 3. Find the expression for f inverse -4. I think this is pretty okay. What we need to understand is f inverse -4 is just f -4, because the equality still holds true, right? Then what we need to do is just put the value in. So this is the expression here. I could just multiply, we call it -1 on top. Okay. So this is how I do this question proficiently. If you have any questions at all, please do let us know, and I'll see you in the next question.